Hi guys, it's been a while since we did a problem on Leetcode, and as you know, being too far away from Leetcode for a long time can be injurious to one's health, or at least injurious to one's coding health. So we are back to doing Leetcode, and I'm really excited to do this problem. This is right now container with most water. It's lead code 11, giving n non-negative integers a1, a2, 3, an, where each represents a point at coordinate I, ai. N vertical lines are drawn such that the two endpoints of the line I is at I, ai, and I is 0. Find two lines. So basically, that's just saying that I'll give you a bunch of an array with values, and these values actually represents the heights of the lines at that particular index. So 0, for example, when your index is 0 here, and ai will be the length at 0, a0. So a0 in this case, for example, is 1. Similarly, the index here is the ai here is 8. So that's just easy. Find two lines which together with the x-axis forms a container such that the container contains the most water. And you may not slant the container, and that's, I guess, um, is not much of a problem. That's already assumed. Now, lines are, I think that slanting is because your area calculations become easier if you don't slant. So max area of the water the container can contain is 49. As you can see in this case, the so let's just start from, imagine we start with a container here. Like, imagine you take the line the at index 1. So, and then uh, this is, I guess, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or if you take 1 to 8, I guess, right? Because 1, 2, 3, I think this is height. As I'm wondering if what is the distance between these. So if it is 0 and this is 1, and I'm assuming that this is 2, but they don't seem to be equally spaced, right? So if I'm assuming, let's see this here, are they the 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 distance between them is just 1 unit apart? If they are 1 unit apart, then it's very easy, because you go from here 1, and that is 2. So that is 1, 1, 2, 3, 4, 5, 6, 7, and 8, right? So uh, that's the x-axis distance between the leftmost and the rightmost multiplied by 1. So that would only give you 8. But if you take the one that he has shown you here, in that case it will be 7 times the height of the last one. So that's 49, and that's why it's coming out to be 49. But why that is the max area in this case, the most water, the container. What if I have any other possible combinations of these lines? So if I take, for example, uh, like this rightmost and this leftmost, is most likely is not going to be the case already, because as you can see, this is 3, and then you will have, if you take from here 1, 2, 3, 4, 5, 6, only be 18, right? So that's not a good combination either. That's not the max area, max container either. So now if you take, for example, this guy and this guy, so then you get 8, minimum of the 2 is still 8, and you got 1, 2, 3, 4, 5. So 8 times 5 is only 40, but this one is 49. So as you can now you can see that it's that this indeed is the biggest um, um, the container with most water. So similarly, now let's take this. There are only two lines, one and one, and of course output will be one. And take this one, 4, 3, 2, 1, 4. This is easy because you got 1, 2, 3, 4 times the min of the left and right. 4 times 4 is 16. 1, 2, 1. So if you were to draw this, let's say 1, 2, 1. So you'll have 1, and then you have 2, and then you have 1. So the minimum height, whatever combinations you use, is going to be 1 only. 1 times the maximum x-axis span could be 2, 1 and 1, so that's why it's 2. So what approaches are possible here? Let's talk about that. Like, what approaches, what algorithms can we can take here? So one of the approaches is the brute force. And as you know, interviewers usually don't like these brute force approaches, but it's good to kind of maybe, couple of minutes talk about that. Hey, look, I do know that that's the approach, but and I know you're not going to like that, but it's not something that we would like to implement in the production code because it's going to be extremely inefficient. So the brute force approach would be that, let's say that you start with two nested loop, kind, like you start with a loop, outer loop with I equal to pointing to this guy, and j pointing to the I plus 1 this guy, and you iterate over keeping the outer loop's index same. You iterate over all the possible combinations in the inner loop, and then you repeat that. You go back to the outer loop, change that pointer index to the next element, and then you go for j equal to I plus 1, you just set and you do the same thing. Now that approach is, as you know, is going to be n square, because you have this nested loop. Anytime you have nested loops, you will have n square. Or if you have nested loops, maybe let's say 3 times, then you have O n raised to power q. So that's why these are usually avoided, because as n increases exponentially, or if n goes to like from 100 to 10,000, you will be basically just your runtime will be exponentially increasing. That's why it's a very bad idea. So let's see what is the next approach we can take. Can we do better than that? So for that, I would say what we can do for that is, how about, let us just say that we start with two pointers or indices pointing to the leftmost element and the rightmost element. And then what intuition can we use here? So now let's just start with I equal to pointing to 1 and j pointing to 8, because this is 1, this is 2, let's say this is 3, 4, 5, 6, 7, 8, or 9 actually. Then 9 minus 1 is 8 though, right? So that this span is 8. So you would end up having area of basically 8. But 8, as you can see, this approach now uh, so this is one container. What should we do then from then on? Now, as you know, if you want to find a better container between these two extremes that we have, what do you think? Where do you think we should move? Should we move this guy, or should we move this guy? Now let's say as you can see, the moving the rightmost guy when the leftmost guy was the minimum is not a good idea, because the minimum you already have here. Unless you, if you move this side, let's say here, and it was even bigger than that, or as long as this guy is the minimum, the leftmost guy, you're basically constrained by your area being limited by that, because you see the you will be changing these x-axis, the span on the x-axis, but your y will be just basically pretty much by limited by the minimum of that element. So the intuition I would say here is that you start with the left two indices pointing to the two extremes, and then you basically adjust them according to which one is minimum of the two. So if the left side is minimum, it makes more sense to basically advance that to see if you have a bigger element, and uh, uh, and then basically calculate area from there to keeping the right side as it is. And if the right side is minimum, like in this case for example, what you would have tried is, now you see it so happens that immediately the right side becomes the minimum of the two. So it makes sense to basically go and try to say if we get anything bigger than that, because that's the minimum, that's the one, that's the constraining factor. Maybe you have an element much bigger than that, and this will happen here, but before that happens, before you reach there, you have to move, and when you move you will find that you'll end up on this element, and this is in this case will be even lesser than what you had last time. Now you will move here, which is basically you'll find that this time the minimum of the two is in the right, so you move right to the one, you basically advance or decrease, whatever you want to say. Then you see now that the same height, and then you will see that you will end up having this area over here, right? So that is the approach we'll take. So when you have whatever side you have the minimum of the two, that is the side that basically moves. Okay, so let's see how we can solve that. Now, as you can see, we are going to try this first time in C++. Most of my solutions so far have been either in Python or in C, but this time we are going to try C++ because that's apparently not that hard as we thought. So what we're going to do is we'll have a variable accumulator, as they call, where we keep track of the largest area seen so far. And then we have left index pointing to 0, and we have right index pointing to now how do we find the, if it was C, we will have int a and comma length, because in C you have to pass the length of the array as a parameter to the function. But in this case, since we are given vectors, STL vectors, it's not too hard either. All we need to do is we have to hide dot size. We need to know that vectors have a method known as size that gives us the length of that vector. And since the indexing in C and C++ happens in starting from 0 to the size -1, so that is why right will be pointing to the rightmost element will be height dot size -1. Now you see what do we do. So now let's start our loop. So the loop will go, we can actually do something like this. You know why? Because we can move as long as they're not same, and when they hit into each other, that's when we can get out. So now what would be the area? Good point of being C is that you don't have to declare everything in the beginning. C++ is that you don't have to declare all your variables in the beginning of the function. Actually, even this would have been allowed in C, where it's inside a block. So let's calculate the area, and the area is going to be height min of, so now we are taking these vertical lines and finding the minimum of the two. So that's your, you basically pass it to the min macro or function, whatever the heck it is. You basically take the minimum of the two lines, two vertical lines, and you multiply that by the total span of right minus left on the x-axis, right? Now all you need to do is that if area is greater than largest area, then we basically reset the largest area to area, and so that part is done. Now all we need to do is move the left and right indices depending upon which one was smaller. So that is, if height, the vertical line on the left is less than the vertical line on the right, then all we need to do is we have to basically advance the left side, else we basically advance the right side. Now you see, if they are same, it doesn't matter, you can basically move either way. So that is why we don't have, we just have less, and then the greater or equal to is basically taken care by here. So, oh sorry, actually this will be, because you're kind of going backward, right? When you're on the rightmost element, you're basically moving to the left. So that is why you have to decrease, not increase. And when you're leftmost, you're moving towards right. So you have to increase. So this is done. At this point, our while loop is finished, and all we need to do is return largest area. And this we'll try to run first. Let's see if we get any success here. Brute force. So I see that there's some problem here. Okay, that's easy to fix because we forgot to comment out these lines. Alright, so that's accepted. The output is as it is. But before we submit, I want to just basically talk about runtime complexity and space complexity. So I haven't, no, I basically left out the point 2 here, which is what do you think is going to be complexity now? Because you see, we're only walking once. So that's why we are walking the array that is given to us, or the vector, whatever you want to call, only once. So that's on. Now that's your time complexity now. And the space complexity also is on, because you see we have not done any extra memory allocation or anything like that. So it is all looking good. Let's try to submit and see if it works. And there you go. It's basically um, we have a success here, and we are getting 24 millisecond faster than 77% of C++ online submissions, and it's all looking good. So what do you think should be our strategy now? Do you think that we can improve upon this solution, or we are basically hit the dead end as far as the optimizations are concerned? So what you think should happen if you find that moving the indices makes no sense, like readjusting? You see, now what's happening is that we don't even care. Now, you know what? I will leave that exercise as a brainstorming exercise for you, as a kind of a homework for you to do, to see if this can be optimized further. Are there any scopes for optimization? And if so, if you can write in the comment section, I would really appreciate. And it's kind of leaving a little bit out is good for all of us, because it gives us, rather than having the ready-made solutions and leaving nothing for you to to go and do as your homework, is not a good thing. So I think there's a one optimization possible here, which is that uh, that if you move to your like when you adjust left and right, there could be a potential optimization, I'm thinking. Because imagine, like in this case, or for example, imagine you are at this case, this black here, sorry, the red here and the black here. Now, why do you think it makes no sense to basically, or even like for example, just take this case. Why do you think it makes no sense to try now this combination? Now imagine we already tried this combination, we got 49. Now should we try the combination with this black line and this red line here? Why do you think it's of no use? Because even though this is smaller, and we are saying that hey, this is the limiting factor and we would like to see if there's anything bigger which was here, so maybe adjusting from going to here was okay, but there was no point in changing or trying out or calculating the area for this combination, because there's no way this is going to be more than that. So I would leave that for your creative juices to keep flowing so that you get to try something on your own. And with that, I will see you in the next video. And my apologies for keeping away from lead coding and not having any more videos to basically watch. So I promise to bring you more videos as time goes by. It's a very fun exercise. It's definitely better than wasting your time on destructive activities like day trading or GameStop or any of these speculative investment activities. Actually, speculation is not even investment. So and that is just one destructive activity. I mean, the life can be full of many destructive activities. So we have to be away from them and come to the constructive activities. And I think lead code is definitely a very constructive activities. It's not only good for the activation of our dormant brain cells, but also to basically have fun while basically trying to exercise our mental capacities. So with that last ending note, I leave you guys to keep trying out more exercises on lead code, and happy interviewing. And even if you're not interviewing and you're just doing lead code because this is the best thing that can happen to you, then all the power to you. And I will see you in the next video. Adieu, take care, bye bye.